Hello guys, welcome to my channel Civil Softwares. In this new series of videos, I am going to post about Introduction to Finite Element Method, which is very much important for structural engineers and as well as other engineering fields. So let's begin with what is Introduction to Finite Element Method in simple words. In simple words, if we have to say, finite element method means breaking down of complex object or a complex system into smaller, more manageable pieces, and then analyzing each of these pieces individually. So what does it mean? It means in finite element method, we take a system which is complex and analyzing such complex system is also difficult. So what we do is we break down that complex structure into finite number of elements and we individually study and find out the properties of individual elements and then we assemble all those elemental properties together and then finally we predict the system level behavior prediction. So as you can see in this little diagram. So the first step is breaking complex system to finite elements. So we first of all break down the complex system, then we analyze individually all those finite elements. Then after gaining the knowledge about the elements, individual elements, assemble. We assemble all those individual elements together and then we study system level behavior prediction. So this is what finite element method is in simple terms. As far as you go and keep on studying it slowly and gradually, you will get to know more. And personally speaking, if you solve one problem of finite element method stepwise, then you will have a clear vision about what we are doing. And I make sure that you understand it. And because we will discuss one example question in one of my videos. So let's go to the next slide. Okay, so here we have the bar element and we are finding stiffness matrix of a bar element in a local coordinate system. So you must have seen this figure. I'm going to explain it clearly to you as far as I can. So this is a simple bar element having certain stiffness K. So what is stiffness? Stiffness is a material property. Okay, so here if you see from Hooke's law, F equals to K. So what does it mean? It means that force is directly proportional to the displacement. So where this displacement comes from? This displacement comes when we apply force. When we apply certain intensity of force, then there is certain displacement in the individual nodes where we apply force. So that displacement is dependent on stiffness, which is a material property here. F is directly proportional to the displacement and this K is actually a proportionality constant which we call stiffness. Okay, so in this bar element you can see this is node 1, this is node 2, this bar is of length L. So we are applying force 1 dash in this node, F2 dash in this node. Why am I putting dash over here? Because I am talking about local coordinate system. In finite element method, it's very important to understand local coordinate and global coordinate. While representing global coordinate, we do not put this dash. If you do not see this dash, this means you are talking about global system, global coordinate system. And if you are studying about the local elements, which may be slanted, which may be curved, which may be of any shape, okay, which may not align with the global XY coordinate, then we put dash over here, which means it's local coordinate system. So F1 dash is applied here, F2 dash is applied here. This individual forces generates displacements U1 dash and U2 dash. Okay, now here we go. We know Young's modulus of elasticity is given by stress upon strain, right? So what is strain? Strain is change in dimension per unit original dimension, symbolically representing strain equals to del L upon L. Now, when we substitute this strain over here, we get equation something like this. Okay, so when you solve this, we get the expression force equals to A by L into del L. So if we compare this with Hooke's law, force equals to K times U, where del L represents this displacement and K represents A by L, we can say stiffness equals to A into E by L, where A is cross-sectional area. So you need to know, a lot of people may not uh, have this knowledge about what cross-sectional area means. So cross-sectional area basically means if you cut this piece here anywhere, then you get a circle, right? So that is its cross-section. Okay, that is its cross-section, and the load is applied perpendicular to the cross-section here, right? So this A by L is stiffness and U is displacement. Now, again, from the Hooke's law, we have force equals to Ku. Here we are applying two forces, F1 dash in this node, F2 dash in this node, right? So F1 dash equals to minus K times U2 dash minus U1 dash. Here are two terms that you need to know. Why is here negative sign? Here is negative sign because it is the compressive force. In compressive force, we put negative sign. So here, if we apply F1 dash here, then at this section, this force compresses the structure, right? Whereas if you see this F2 dash force, it is acting away from the member. It is pulling, whereas F1 dash is pushing. So pulling force is positive, which is tensile force, and F1 dash is pushing. That means it's compressive force. So this is negative and this is positive. Okay, we have to be careful about the sign conventions here. Now, another term is u2 dash minus u1 dash. How is this displacement? This is a displacement because here this expression gives you the relative displacement because we are applying two forces. It is giving two displacements. So we have to find out the total displacement, right? Which is relative. Okay, we have to calculate the relative displacement. So we have to subtract this. Okay, and in F2 dash it's positive because it is tensile force. So if we represent this simply in matrix form, we get this expression right over here. So now how did I get one positive minus one negative here and minus one negative and here positive? So let's go into this equation. This is nothing but representation of equations. So in F1 dash, you can see here, if I open this bracket, this minus k and minus u1 dash makes u1 dash positive in the first expression. So u1 dash, at first, it should be positive. And if we multiply minus k with u2 dash, it gives minus 1 times u2. So here it's minus. And if we look in this expression, if you open this bracket, it gives k times u2 dash is positive u2 dash. So this positive u2 dash place is here. And k into minus u1 dash gives minus 1 and its position is over here. So this is simple matrix representation. Now if you compare this with f dash equals to k dash u dash, so I'm repeating it again, we are putting here dash because we are talking about the local coordinate system. So if we compare it with this here comes k dash e, which represents k times this matrix, k times 1 minus 1 minus 1 1 times u dash. So this over here is k dash e, which is the stiffness of the bar element in local coordinate. I hope you guys have understood this simple bar elements stiffness matrix, and in next video we will talk about how to change local coordinate into global coordinate and vice versa. Thank you very much.